Hello out there, welcome to this tutorial on sequences and series. If you are joining us now, check the description section of this video on our YouTube channel to get the link to the playlist containing all the videos on sequences and series. In this video, we'll be looking at word problems leading to geometric progression. We take our first problem. Problem 1. A boy puts $2 into a piggy bank. A week later, he puts $4. 2 weeks later, he puts $8, and so on. How much money does he put in the bank in the 15th week? Calculate the total amount of money in the bank in the 15th week. So in our solution, he put $2 the first week. That will represent the first term, and the second week he put $4. The third week he put $8, and so on. This is forming a geometric progression since 4 divided by 2 gives 2, 8 divided by 4 gives 2. But if you are going to look at it as an arithmetic progression, 4 minus 2 gives 2, but 8 minus 4 does not give 2. So it is not an arithmetic progression. So we are treating it as geometric progression, where the first term is 2 and the common ratio is 2, and the number of terms as given in the question is 15. The first part of the problem is to calculate T15, since we are looking for the amount of money he put in the bank in the 15th week. So for a geometric progression, Tn equal to a r raised to the power n minus 1, and since we are looking for T15, we have T15 equal to a, that is 2 times 2 raised to the power 15 minus 1. Since n is 15, this will give us 2 times 2 raised to the power 14. And applying law of indices here, this is 2 raised to the power 1 plus 14 will give us 2 raised to the power 15. And this is giving us $32,768. That is the amount of money he puts into the piggy bank in the 15th week. Now the second part of the problem says we should calculate the total amount of money in the bank in the 15th week. So here we are going to look for S15. So we have our Sn equal to a into r raised to the power n minus 1 over r minus 1, since r is greater than 1. So this formula is the convenient one for Sn. So our S15 will be 2 into 2 raised to the power 15 minus 1 over 2 minus 1. So that we will now have it as 2, since 2 raised to the power 15 gives 32,768, then minus 1 will give us 32,767, then over 1. So we don't need to put over 1 since 2 minus 1 is 1. So that 2 times 32,767 gives $65,534. That is the total amount of money in the bank in the 15th week. So we are done with problem 1. We go to problem 2. Problem 2. The initial annual salary of a company is $15. If there is 15% rise on the salary each year, calculate the amount of money a worker would earn in 25 years. So in this problem, So we can form a geometric progression from here. Since there is a rise of 5% every year, so the first salary is $15, then the second salary will be 15 times 1.05, since the total amount will be the original amount multiplied by 105%, because the second year it is going to be 105% of the first year. So that we will now have it as 15,000 times 1.05, since 105% is 1.05, and the third year will be 15,000 times 1.05 squared, and so on up till 25th term. So we know that our first term here is 15,000 and our common ratio is 1.05 and our n is 25. Now we are to calculate the total amount of money a worker will earn in 25 years. So we are looking for S25. So we still remember our Sn is equal to A into r raised to the power n minus 1 over r minus 1, so that S25 will be A, which is 15,000, into 1.05 raised to the power 25 minus 1 over 1.05 minus 1. This is 15,000. 1.05 raised to the power 25 minus 1 gives 2.38635 over 0.05. 1.05 minus 1 gives 0.05. Simplifying this from our calculator, we have 715,906.48, which represents the total amount of money a worker will earn in 25 years. So that's the end of solution to problem 2. We go to problem 3. A ball dropped from a platform 20 meters above the ground. The ball rebounds 90% of each of the heights it is falling. Find the total distance traveled in 20 bounces. Okay, so here the first bounce is 20, the next one is going to be 20 times 0.9, because this is reduction, that is the ball rebounds 90% of each of the heights it is falling. So the second bounce is going to be 20 times 0.9, and the third bounce will be 20 times 0.9 squared, and so on up till 20th term. So we are calculating the distance traveled in 20 bounces. So our first term here is going to be 20. Our common ratio is 0.9 and our n is 20. Here we are looking for S20. So still maintaining our Sn equal to A into 1 minus r raised to the power n over 1 minus r. So our S20 will be A, which is 20 into 1 minus 0.9 raised to the power 20 over 1 minus 0.9. This is going to be 20 times 1 minus 0.9 raised to the power 20 from our calculator gives 0.87842 to 5 decimal places. This is over 0.1. Simplifying this from our calculator, we have 175.7 meters, that is to 1 decimal place. That is the end of solution to this problem 3, and this is where we are ending this tutorial. I hope you enjoyed it. Remember to subscribe to our YouTube channel. Also hit the notification bell to get updates for all our new videos. Remember to check the description section of this video on our YouTube channel to get the link to the playlist containing all the videos on sequences and series. Until we come your way again, goodbye.